Hi guys, Dr. Gillard here once again. Let's do some spinal anatomy, shall we? It is, what is the date? It is the spring 2020. It's week 9. It is Tuesday afternoon. And here we go. Transverse processes of atlas is where we left off. Remember, atlas has 2 transverse processes, just like everything else. They're kind of not really double-strutted. I mean, sometimes they're faintly double-strutted enough to have an anterior and posterior tubercle. They do project from the lateral masses of atlas. Remember, atlas has no body, right? It's made up of 4 structures, really. There's a lateral mass, which is really like the articular pillars. Lateral mass is made up of the superior and inferior articular processes. And there is an anterior arch and a much bigger posterior arch. That's kind of an overhead view of atlas, right? Then it has a transverse process sticking out here. There's no lamina for atlas. There's no body here. It does, the dens of C2 actually fits right in here. Remember, we have the colliculus atlantis here, and there's a transverse ligament of atlas like that, and it kind of holds the dens in there. And then, of course, the spinal cord lives right here, right? This is the posterior arch. Spinal cord lives right here. Super important. There's no cauda equina here. It's the nerve roots are embedded in the spinal cord. Then, just to finish things off, there's a little bump called the anterior tubercle, a little bump called the posterior tubercle right there. Okay, we can go home now. Just kidding. The transverse processes are the largest in the cervical spine. Each one does have its own transverse foramen, maybe not out that far, like that, for the passage of part 3, V3, of the vertebral artery. Okay, yeah, why draw it when we can look at it for way, all right? So here's the atlas sitting on axis, C1 sitting on C2. There's the anterior arch. There is the lateral mass, which is made up of the superior articular process. Pars would be right about there. So all that is superior articular process. All this, inferior articular process. Colliculus atlantis is right here. But the star of the show here is this posterior arch. And there's the posterior arch. And it's got a knob on the back of it called the posterior tubercle. And we're going to talk about, so do this now. There's a groove right here for the vertebral artery called the groove for the vertebral artery. The vertebral artery, of course, comes right out of here, does a crazy bend and goes through here and goes into the dura and goes up. All right, I think we got all of that. But you can see, I mean, you call that double-strutted transverse process. I guess maybe but it's not so marked double-strutted, because I guess you could say there's an anterior tubercle and there's a posterior tubercle, but kind of definitely a strange beast. Transverse processes can also be very asymmetrical. Sometimes one is short, sometimes one is long, sometimes it's bent. Yeah, all kinds of things. There are no oncovertebral joints here. There's no Batman's ears with regard to the atlas. We talked about the anterior and posterior tubercles, which come off the anterior and posterior arch. There's a nice CT slice, coronal slice, right through the dens. Very cool. Now we can see the lateral masses of atlas really nicely. I mean, I could draw the line, would be right about here. That's the pars interarticularis. This would all be superior articular process of the lateral mass, inferior articular process of the lateral mass. Dens is in the middle. And look at the transverse processes. They're definitely, this one's kind of long and sticking out further. This one's kind of bent a little bit. So definitely some weirdness going on there. You can tell someone's age by looking, get a good idea of their age by looking at the superior articular process. So first of all, they're more concave in shape, even when someone's younger. The inferior articular processes, the facets are flat, so you can always tell which way is up from down. This is definitely up. They're also often more kind of elongated, like this shape here. The ones, as we'll see below, are more just like round circles and flat. Those are the inferior articular process of the lateral mass. And these are superior articular process, or you could say facets. I wouldn't mark that wrong if there's a clay blob sticking right there. Facet of the superior articular process of C1. And some of the facets, they're double facets. I mean, so you could have an articular pad of cartilage here. You could have another articular pad of cartilage right here. And so it's not unusual, sometimes even 3. So it's not unusual for them to be like that. The other thing about aging, the deeper this concavity is, the older the patient is. This patient's not very old because this is very shallow. But you can see in the lab we have some you can look at. They're very deep and scooped out. And you can tell that it was an old person. All right. Without looking at the words, I'm covering up with my hand like you can see that. Is a superior S to I view or I to S view of the atlas? That's I to S view. How do you know? Because these are flat. I've put this on the test before, on the lab test. Make sure you know up from down. So these are never, they might be tiny bit concave, but they're more round and they're not nearly as concaved as the superior articular process facets are. Okay, and these are also can be grossly asymmetrical, just like the transverse processes, these inferior articular processes. 63% of them, in fact, are asymmetrical. 36%, or we're back to superior articular processes. 37% of superior articular processes have 2 to 4 distinct facets, so that's not at all unusual. I drew this already, but here, this you could consider this one facet here, and another one here. If they were alive, you'd see a pad of cartilage right here and here. They can have up to 4 of those things. Anterior arch of atlas. So remember that's part of the ring of atlas, made up by anterior posterior arch and the 2 lateral masses. This one is smaller than the posterior arch. It has a little bump on it called the anterior tubercle. Anterior tubercle is important because it attaches to the anterior longitudinal ligament. Remember, the anterior longitudinal ligament attaches there. And the superior oblique fibers of longus colli muscle also attach there. Posterior, it contains a facet. So there's a little articular pad of cartilage on the posterior portion of the anterior arch. Take a wild guess what that connects to. That connects to the dens, right? So if we had here's kind of the dens like this. Okay, there's a spinous process back there. And here's the anterior tubercle of atlas. There is, let's see, can I change colors? There is a facet here. There's a pad of articular cartilage right there, and another pad of articular cartilage on that anterior arch itself. And so this one would be called the facet for the dens, and this would be called the facet for the anterior arch of atlas. And these two form a very, very important joint called the atlanto-dens interval, or the ADI space. When you're taking x-rays, you want to make sure you always look at that ADI space to make sure it's not bigger. It should never be greater than 3 millimeters. With software nowadays, it's really easy to get these measurements so you'll be able to see. Right? So here's a kind of a P to A view. And we can see, this is the anterior arch right here, and we can see a huge crater, right? That's the facet for the dens, and the dens would have one. Did I put one in here? Yeah, I did. This one's a little different shaped. But there's the facet for the anterior arch of atlas. All right, we'll look at this tomorrow, the atlas. In this ADI space, again, it's the articulation between the dens and anterior arch of atlas should be snug. there's a big ligament called the transverse ligament of atlas that holds it, that interval tightly. And not a big one with numbers, but here's a number you have to remember always. The ADI space should never be greater than 3 millimeters. If it is, you don't adjust the patient. Don't put any force into their upper cervical, especially if they just had a car accident. You could kill them. Okay, so it could mean instability of atlas axis. So if you did an adjustment or they had some kind of a whiplash injury, they could injure their cord and become paralyzed, or even worse, dead. Okay, so here's a picture. You can see pretty snug. It's definitely not. There's not any separation of this at all. There's that dens again. This is a CT cut through there, and it looks real good. There's no separation. Posterior arch of atlas. Again, that's the second member of the atlanto arches. First member was the anterior arch. It's much larger. In fact, about 2/3 of the entire ring of atlas is made up by the posterior arch. And it contains a bump on its posteriormost surface, which is called the posterior tubercle. Its attachment site for, among other things, ligamentum nuchae, serves as the origin for rectus capus posterior minor muscle. Its lower border's attachment site for ligamentum flavum. So we'll look at this more when we look at ligaments. I'm going to do a little one on ligaments to get you ready for your lab in a second here. But the inferior surface of the posterior arch is where ligamentum flavum actually ends. That's the end of it. Ligamentum flava is plural. We'll talk about that. I think we talked about ligamentum flavum. It's the yellow ligament. Yeah, we did. It's kind of got some retractile properties in it. The upper border of the arch, there's no more ligamentum flavum, but there's a muscle or a ligament kind of akin to ligamentum flavum. That's called the atlanto-occipital membrane. It's a membrane because it's thinner. We'll look at that more when the time. Actually, we'll look at it right now, I guess. I think this is just kind of getting ready for lab, but here it is. This is a P to A view of atlas. Here's the posterior arch of atlas right here. There's the lamina of C2 down here. No lamina here. These are posterior arches. But this is the old ligamentum flavum that goes all the way down the spine. There's right and left side. And yeah. So that connects to the inferior part of the posterior arch. And then no more ligamentum flavum. Up here is the posterior atlanto-occipital membrane. Okay. So that's kind of neat. Nice picture. You can see how V3 of the vertebral artery does that crazy bend after it goes through the transverse foramen. It's going to poke a hole in the posterior atlanto-occipital membrane and go in a little groove right here called the groove for the vertebral artery. So that's an important structure. Another thing, kind of jumping way ahead, but this region right here, this kind of lateral part of posterior atlanto-occipital membrane, it likes to become calcified. I mean, some research papers find this up into almost a third of humans, this becomes calcified. When I went to school back in the day, they thought this was a contraindication for adjustments because it might rip the vertebral artery. I think that's pretty much been disproven. Still safe. I'm pretty sure in our clinic it's still safe to adjust people with this calcification. That's called a posterior ponticle when that calcifies. Right, so there's that groove for the vertebral artery. It's officially on the posterior inferior surface of the articular process. And who cares about the groove? Because boards and me, we like questions about what travels in a groove or what comes out of a hole. And there's three things that are transmitted. What does that mean, transmitted in this groove? It means carried or run within this groove, transmits. So the V3 of the vertebral artery, make sure you know the parts. We covered those last time. Vertebral vein and the suboccipital nerve, which is the dorsal rami of C1, spinal nerve. All right, so there's a nice look at the groove for the vertebral artery. There is no bony calcification over here, right? Some specimens have a nice bony kind of a ledge right here, or bridge, but not this specimen. You can see the posterior tubercle quite nicely here as well. Okay, colliculus atlantis. Can we see it here? It's not very good. I got a better picture. So this important transverse ligament of atlas runs between the colliculus atlantises. There's one of these things on the lateral mass, and they hold the odontide process in place. They're very important. Actually, make a note about this slide. Where does it run? I didn't say where it runs. It runs between the lateral masses, so I'm going to add that to the notes. Okay, super important for stability. Oh, there it is. It rises from a tubercle on the medial surface of the lateral mass. So I'll forget that. Okay, there's a nicer picture. You can see it right there, more in focus. And yeah, there'd be a ligament, the transverse ligament of atlas is super thick and super strong. It'd be here, and then the dens would go right in here. And that's what holds C1 and C2 together, so that's a very important structure. Quick look at lab. So we have a lab coming up next hour, our lab worksheets. We already went through this, but that's the posterior atlanto-occipital membrane would be here. This would be the ligamentum flavum, the end of ligamentum flavum. Another one would be right down here. And they run all the way down, don't they? These are joint capsules, just like around all Z joints. You could call them articular capsule of the Z joint. And what else do we need to see here? V2. What vertebral artery is that right there? V2 is there. It turns into V3 here. It's V3 here as well. It dives through that posterior atlanto-occipital membrane. The posterior atlanto-occipital membrane is connected into the foramen magnum, which we talked about, the posterior lip of it here. Right? So this is the superficial layer. I mean, there's more layers on the top, right? There's a supraspinous ligament, and there's a ligamentum nuchae, the nuchal ligament that covers this. So, I mean, is this really the superficial? It's kind of the medium superficial. There's yet another ligament over the top of this thing, 2 more ligaments. But we'll just say it's superficial ligaments for now. If I remove these, if I cut the pedicles and pull off the posterior arch, pull off the lamina here, and I pull off these ligamentum flavum and posterior atlanto-occipital membrane, what's deep to this? We have kind of a medium level now. And this is a continuation of the posterior longitudinal ligament. So this is stuck to the body, this new one of C3, stuck to the body and the dens of C2. And yeah, so this is a kind of a middle layer, but there's ligaments deep to this even. So this is called the tectoral membrane. Tectoral membrane, and this is called the posterior longitudinal ligament, and we know that one, right? It runs all the way down the back. Now we have a deep layer, and I mean, technically there's even one ligament, the apical ligament, is even deep to this picture. But just in general, this is kind of a deep layer. Here's that transverse ligament of atlas I was talking about. Right here. See this guy? It's a member of the cruciform ligament. Cruciform means cross, and you can see we do have a cross right here. So cruciform ligament has a kind of a superior longitudinal band or fibers and an inferior longitudinal band or fibers. And then it's got this transverse band, or just the transverse ligament of atlas. Super important. Where does this insert? Transverse ligament of atlas. Colliculus atlantis. It attaches to the kind of those little bumps on the lateral masses. If I go a little bit deeper and take this cruciform ligament out, the tip of the dens would be right here. So we have two powerful ligaments connecting up to the occiput here, the foramen magnum, kind of the inside, and another one here. These are called the alar ligaments. The alar ligaments. Right? And those guys are really important for stability as well. And there's an apical ligament behind this. We'll get to those tomorrow. Okay, did I get to them all? There's also this one. Some people just say this is kind of part of the posterior atlanto-occipital membrane, a thickening in the outside, but other people call it its own ligament. So this is called the accessory atlantoaxial ligament. So that also is important for stability. Of all of these, the two most important for stability are the transverse ligament of atlas, and then these alar ligaments are really important. Got it? Here's just another view. PLL, this is pretty deep, right? There's the posterior longitudinal ligament, turns into the tectoral membrane, which goes all the way to the foramen magnum. If you take this out and go deeper, then you can see the cruciform ligament here and the accessory atlantoaxial ligaments here, and the alar ligaments here, and the joint capsules. Are we good? I kind of already drew this. You can see something here, though. Look at this. There's no bony bridge here. Now this is going into the plane of the page, right? This posterior arch is deeper. This is more elevated. But now we have a bony bridge. Posterior atlanto-occipital membrane, a piece of it has calcified and turned into bone. It's called the posterior ponticle. And the hole through there, now we have a new tunnel through there. That's called the arcuate foramen. Arcuate foramen. Getting ahead of my slides today. Just a real nice picture of atlas and axis sitting on top of one another. There's the dens, of course. Transverse ligament would be right there. Colliculus atlantis would be right here. If we go back, we can see them. There's colliculus atlantis would be here and here. Are we good? There's a practice thing. I think this is on your lab sheet here, so make sure we went over all this, so I don't need to say anything. I can say this is lateral mass here, colliculus atlantis. Everything else is straightforward. That's the groove for the vertebral artery here. Yeah, this is pretty easy. Lab. There's the answers. And I lost track of my time, of course. Let's go a little further. We talked about the posterior ponticle. It covers the groove for the vertebral artery in about a third of humans, 35% of humans. Some races more than others. It's kind of like a ligamentum flavum that's calcified, but yeah, it happens. Why it happens so much, we don't know. When the ossification occurs over the vertebral artery and the groove for the vertebral artery, then you have, it's called a posterior ponticle. I explained that. The hole that it creates is called the arcuate or arcual foramen. There's another picture of it. So there's nothing here, but here you can see a nice bony bridge. Here's a double posterior ponticle, right? There's two arcuate foramen. There's a little cartoon vertebral artery going through there. Okay, we good? Really nice colliculus atlanti, really nice developed right here and here in this one, this specimen. And this one, I mean, I guess you could say these are still kind of double strutted on this one, because there's definitely a posterior tubercle here. See how anomalous they are? On the ones that we have, they're not really double strutted like this one is. So they're quite anomalous. So this is what you have to watch out for on X-ray. So remember, X-ray is like getting run over by a steamroller. So this is only two-dimensional, but you can clearly see this patient. In order to see it this nicely, it's got to be a bilateral posterior ponticle, and that's what that is. All right, let's see where we're going to stop here. Well, we'll just do one more thing here. So C1 and C2 spinal nerves are always interesting. Headaches are associated, chronic headaches are associated with irritation of these nerves. C1 spinal nerve, it doesn't have a hole to come out through. The C2 comes out between C1 and C2 neuroforamen, but there is no neuroforamen between C1 and occiput. So it just kind of leaves by coursing over the superior portion of the superior anterior portion of the posterior arch, specifically between the vertebral artery and the start of the posterior arch. And then it splits into an anterior and posterior ramus. Posterior ramus is clinically important because that gives rise to the occipital nerve, and that's the headache nerve. Irritations of that thing, definitely. There's a lot of research on that and headaches. C2, as I said, the C2 spinal nerve leaves as normal between C1 and C2. Here's just a picture of where we're going, but here's this region. We're going to talk about this suboccipital triangle. We'll save that for tomorrow. Really high-tested region. I love the suboccipital triangle. Boards love it. Medical, chiropractic, physical therapy. Got to know. This is like the headache zone here. So you got to know this stuff. So here's C2, spinous process. There's the posterior tubercle. There's rectus capitis minor is digging into that posterior tubercle here. We'll get into the members of the suboccipital triangle, but there is the C1 coming out right on the kind of the origin where the posterior arch arises from, so that the anteriormost portion of the anterior arch, and the vertebral artery kind of comes out right between there. The headache nerve goes right up like that to these, and these all innervate the suboccipital triangle here. Right? C2 is down here. You can't see it coming out the vertebral foramen, but there's a neuroforamen for it. And I'll let neurology talk about this. Curvature plexus, a lot of ways to pronounce that. All right, we'll see you tomorrow.